Just one. So first of all, confirm that the screen is visible to all of you.
Sir, your
Can
voice is
everyone see the
unstable,
screen?
sir. Sir, your voice is unstable.
Okay. Okay, just 1 minute. Let me.
Sir, your screen is visible.
Okay. Okay, so now my voice is clear.
Yes, sir.
Is okay.
Good evening, sir.
Yeah, good evening. Good evening, everyone. So,
Sir, could you say that in chemistry, what is the first chapter we're gonna start, sir?
okay, you haven't started with any chapter from chemistry?
In school, sir?
No, here in coaching. Here, has any chapter of chemistry been started?
No, sir.
No. Okay, I'll discuss with ma'am and let you know.
Okay, sir. Sir, like for my exam, sir, I have one chemistry chapter, one physics chapter, and one biology chapter.
So your bio chapter is complete. Manisha ma'am might have completed your chapter.
No, sir, not yet. Even in school, also they are so lagging behind before test.
Okay. So in physics, which chapter is coming?
Force and pressure only, sir.
Okay, only force and pressure is coming, and that we have done. Now we are
Yes,
completing
sir.
your friction. Once we complete friction, I will ask you, ma'am, and I will let you know.
Yes,
Today
sir.
only I will ask ma'am and let
Sir,
you know.
could you explain little bit about atmospheric pressure, sir? In school today, they just
Atmospheric pressure. Okay.
yes, sir.
Okay. So
Sir, and also we will teach about numericals, sir.
okay, see, I think a number of you are having difficulty with pressure and atmospheric pressure. Okay, a number of you may be facing some problems with the pressure and atmospheric pressure. Let's see pressure. Yeah, Krishna,
Yes, sir.
do you have any doubts?
Yes, sir. I'm just confused with the pressures.
Okay. So I observe that many of you are having problems with pressure. See, the pressure is an idea, or pressure is a physical quantity which describes how the effect of force will be. It helps us to explain the effect of force. For example, we have studied that force can change the shape of an object. We have studied that force can change the state of motion of an object. Different things can be done with the help of force. Okay, here we will see the effect of force. It depends on the area of contact. Okay. So how the effect of force depends on the area of contact. So here we have the perpendicular force or the normal force acting per unit area is called as pressure. So we first define pressure. So when you apply a force on an object, see, pressure is defined as force per unit area. So whenever you are applying some force on an object, so you are applying the force on a certain area of the object. Now the effect that will be brought about, it depends on how much area you are applying the force. Okay. So for example, we have a wooden block over here, and on this wooden block, if we try to apply a force, so the effect of our force will depend on the area on which we are applying the force. So here the perpendicular force acting per unit area, or we also call it as the thrust per unit area, to be the pressure. Okay. See, suppose if you have here a nail, we have here a nail, and we, as we know that a nail has a pointed end, right? A nail looks something like this. So a nail has a pointed end. If I put this nail over here on this box and try to hammer it, so I am applying some amount of force. See, the two cases I am taking a nail over here, and I'm also taking a coin, and I try to hammer both of them on this wooden block. So if I hammer both of them on the wooden block, will the effect be same or will it be different?
Yes, sir.
It will be different. The iron nail will go inside the block, whereas the coin which I have taken, it itself will become flattened. Okay, it will not go inside the wooden block. On both of them, even if on both of them I have applied the same amount of force, still the effects will be different. The reason is that the pressure exerted by the force is different. Okay, why? Because one of them has a greater area of contact with the surface, and the other one, that the iron nail has a very small amount of area in contact. You can see here the area of contact of the iron nail is very small. The tip of the iron nail is very small. Hence, the area of contact of iron nail with this wooden block is very less. Therefore, the pressure will be very high. For the same amount of force, you will have a high amount of pressure that is exerted by this nail on this. Okay. So pressure, it describes the
Sir, is the
amount of yes.
sir, the pressure is high because the area of the nail to the tip is very less, right?
Yeah, if the area is less, then the pressure is high.
Sir, if the area is high, pressure is less.
Yeah, if the area is greater, then the pressure is less.
So can you just write the definition of area one? Sorry, of pressure.
The pressure is equal to unit A.
Force per unit area, the perpendicular force acting per unit area on a surface. Okay. So
Sir,
I'm
I
writing
have
here
a
pressure.
question, sir. Uh,
Yes.
sir, is it fine if I type in the question is a bit long, sir? By saying it will be a little bit disturbing to everyone. So can I type in a chat box, sir?
Uh, can you repeat your question?
Sir, I have a numerical question, sir. I didn't understood the numerical. So is it fine if I type in the chat box?
Yeah, just you can type in the chat box, or you can
Yes,
share
sir.
in the help and support group also. You can
Okay,
take
sir.
a click and share in the help and support group.
Yes, sir.
Okay. So we define pressure as the perpendicular force acting per unit area. Okay. The SI unit of pressure is Pascal. Pressure is measured in SI units of Pascal, and the formula of pressure is given as force per unit area. So as we observe here, the pressure is inversely proportional to area. Smaller the area, greater will be the amount of force. So if you want to increase the area, you can just decrease the pressure, or if you want to decrease pressure, you can increase area. So we have seen different concepts where we somewhere at some places we need to
Sir, your voice is
increase
very
the area
unstable.
of contact. At some place,
Sir, it keeps breaking.
all of you.
Huh, sir?
Yes, sir, it's breaking.
Yes, sir.
Yes, sir, it's
It is
breaking.
breaking, sir.
It's unstable, sir.
Okay, just 1 minute. I'm taking care of it. Just 1 minute. Okay. Okay now?
It is still breaking,
No,
sir.
sir, it's breaking still. It is breaking still, sir.
So I was not facing issues with anyone. Just for this class only.
Yes, sir. Now it is okay, sir.
So see, pressure is defined as force per unit area, and hence we write pressure to be force by area. So at some places we may need to increase pressure, and at certain places we may need to decrease pressure. For example, suppose we observe the school bags. The strips of the school bags, the strips of the school bags, they have broader strips. All the school bags, they have broad strips. Why it is necessary to make broad strips in the school bags? Why don't we have thinner strips?
Sir, it has broad strips because we may not get back pain. And we have to carry the weight, sir.
Yes,
Sir, if we have the broader, sir, if we have the broader strips, our back feels comfortable and also we won't feel pressure on our shoulders.
Sir, one more
okay.
thing,
Sir,
sir,
it's the
is
weight
like,
of the bag, sir.
sir,
Sir,
the weight of the bag will not have that much pressure
Yes,
towards one area because the area is larger in the broader strips.
The area of the contact is more, so like the area of contact is more, so the pressure.
yes. So again, the
the
role is of
area
the
is
area
more,
of
sir. So
contact.
the
If
pressure
you
will be
have
less.
a big, yes, so definitely that. So definitely, area plays an important role in finding out the pressure or in adjusting the pressure. At some places, we may need to decrease pressure. For example, in the case of iron nail, we make sharp iron nails. Iron nails, they are made sharp point. The area of contact of the iron nail is very less, and hence, if you apply some amount of force on it, so the iron nail will go deep inside the. It will increase the pressure. So at some places we may need to increase the area of contact, and at some places we may need to decrease the area of contact. Got it? So pressure is defined in terms of force per
Sir,
unit area. The SI unit of pressure is Pascal or Newton per meter square. You can
sir,
So
Okay, so who was having the doubt in some questions? Someone was about to share the question through the chat group.
Yeah.
So have you shared your? Uh,
Sir, I have it out.
Yes, sir. I'm
yes,
last.
have
Yes,
you
sir.
shared
I'm
your
typing.
question?
Yes, sir. I'm typing, sir.
Sir, I have
Okay,
it
you
out.
can type it
Can
and
you
share.
give an example of
Yes.
Can you give an example where the area should be low and the pressure should be high?
Yes, of course. For example, when we develop iron nail, so the nail to increase the amount of pressure.
Sir, your voice is breaking a lot.
Yes, sir.
We can. Okay, it breaks.
So now it is set, sir. Like now it is okay.
So
Now it is okay, sir.
if it is fluctuating, so I need to make some settlement just now.
Sir, like in for some time it's just breaking or it is setting it to.
Okay. So let's continue here. Small problems may be there. So here we have got the pressure as force per unit area or Newton per meter square. So till you type your question, let's move on to atmospheric pressure. What is atmospheric pressure? So atmospheric pressure, it is the pressure exerted by the Earth's atmosphere. The pressure exerted
Sir, is sent.
So where have you sent it?
Sir, 1 minute. Yes, sir. I sent.
The pressure exerted by the Earth's atmosphere is called atmospheric pressure. So see how it will exert a pressure. Okay. So this is a nice question and it will explain you the concept of pressure. So just I'm giving this question to everyone. Let us see. Everyone will try to understand this question. Okay. So here is the question. You have a girl weighing 50 kilograms standing on pencil hills, each having an area of 1 centimeter square. An elephant weighs 2000 kilogram and foot area, which of the two exerts more pressure on the floor? In your question, you must look up. There must be an area of the elephant also given.
Sir,
Just
by
check out.
seeing the
It should
question, we
also be
can.
given with the.
Sir, actually, the elephant keeps the more
Yeah,
pressure, but how to solve? I'm not getting.
no. I want to know there is a foot area of elephant also.
Yes.
Just see, read this question here. An elephant weight 2000 kilogram and foot area. So here should be the foot area of the elephant.
Yes, sir. I need to say 1 minute.
Yeah, so see it
It
and
is
then
25
tell.
centimeters
So till now
square.
you find. Okay, it is 25 centimeters square. Okay. So here we put area is 25 centimeters square. 25 square centimeter. Okay. So which of the two exerts greater pressure? Now see, first of all, to find out given as force field area. So if I know the amount of force, I know the area, so I can find out the pressure. And also the SI unit of pressure, force should be measured in Newton. area should be measured in meters square. So pressure should be equal to, pressure will be in Newton per meter squared or Pascal. So let us first find out the force in Newton and area in meter square. So first we talk about the girl. The girl weighs 50 kilogram. Now the mass of the girl is given as 50 kilogram. We'll see what is the weight of the girl. So the weight of the girl, or the force that the girl exerts on the earth. When I'm finding out the weight, I'm actually finding out the force which girl exerts, the girl exerts on earth. So if you know the mass, you want to find out the force or the weight of the object, then it is equal to mass times acceleration due to gravity, which is 9.8. So you must multiply its mass by 9.8, which we can take for all calculations purposes. We can take this to be 9.8 to be approximately 10. So we can take here this 9.8 as 10, and hence the weight of the girl would be 50 multiplied 10, and hence it is 500 Newton. So the force that girl exerts on the earth is equal to 500 Newton. Any object which is lying on the earth will exert a force equal to mg. Any object. Okay. Any object which lies on
Sir,
the earth will exert a force. Yes.
sir, I didn't understand it. Can you please explain it again?
See, all the objects, they are attracted towards the earth. If you are here lying, this is your surface of the earth. All object, a small object, a heavy object, all the objects which lie on the surface of the earth, all the objects, they are attracted towards the earth. They are attracted by the gravity of the earth, and the force with which earth pulls them is equal to mass times acceleration due to gravity. G represents gravity. Okay. So the force that every object exerts on the earth is equal to mass multiplied gravity. So mass we know here as 50 kilogram, and gravity is constant, which is 9.8. Okay. Roughly for all calculations, this value of G can be taken as 10. So value of G is 9.8, which can be approximated to 10. So every object which is lying on the surface of the earth will have a force of mg acting on the earth. Right? Suppose I want to know how much of the force is exerted by you on the earth. That means what is the gravitational pull by you by the earth on you? So it will be equal to mg. Whatever is your mass multiplied by 9.8, that will be the force that the gravity acts on you. Got it? The force which the gravity acts on you will be equal to mg.
Okay, sir.
Okay. So
Sir,
this
your
force
voice
is
is
equal to
breaking.
mg. Hmm.
Sir, now
Is it okay now?
it is okay, sir. It is not breaking so
I don't know
heavily,
why.
sir. Just sometimes it's breaking and it's just stop.
Right now, electronic was working well. Everything works well. Let me check it. So here we have 500 Newton of the force. We know, okay, let's come here. For the girl, force is equal to 500 Newton, and area of contact is given as 1 centimeter. So we need to convert this 1 centimeter square to meter square also. Okay. So area is given as 1 centimeter square. We'll convert this to meter square. As we know, 1 centimeter is equal to 1 over 100 of a meter. Am I right? 1 centimeter is equal to 1 over 100 of meter. 1 centimeter square will be equal to 1 over 100 square of a meter. So this is 1 over 10,000 meter square. This is the area of contact. So the conversion unit you can also remember for 1 centimeter square. You have 1 centimeter square is equal to 1 centimeter square is equal to 100. Yeah.
Sorry to disturb you, sir. This is the continuation of the solution, right?
There is.
This is the continuation of the solution, right, sir?
Yeah, this is the continuation of the solution only. We have 1 centimeter square is equal to 1 over 10,000 of centimeter square.
Yes, sir.
Wherever you need to convert centimeter square to meter square, this is the formula that you'll be using. Since 1 centimeter is equal to 1 over 100 of meter, so if you square them both the sides, you will get 1 centimeter square is equal to 1 over 10,000 meter square. And now we can find out the force exerted by the girl on the earth, that we have known 500 Newton. So pressure by the girl, pressure exerted by the girl will be equal to force upon area. Here force is 500 Newton divided by area, which is 1 over 10,000. Okay. So if you solve this out, you'll get 500 multiplied with 10,000. So this is the amount of pressure that is exerted by the girl on the floor. Okay. This is equal to 5 multiplied 10 to the power 6 Pascal. So a pressure of 5 multiplied 10 to the power 6 Pascal is exerted by the girl on the floor. In the similar way, we will also try to find out the pressure exerted by the elephant. So for the elephant, the area of contact is given as 25. So let's see for the elephant. For elephant, the mass is 2000 kilograms. Okay, is this okay up to here? Everyone has understood up to here?
So no, sir. How 1 by 100 came, 1 by 10,000 came below 500.
Uh, this is conversion. Okay, this much is clear. 1 centimeter equal to 1 by 100 of meter.
Yes, sir.
Okay, if you square both the sides, then you will get here 1 centimeter square.
Sir, then it will just be 100 centimeters, 1 by 100 meters square, right, sir?
So this is 1 centimeter square. And if you square this side also, so you will get 1 over 10,000. The square of 100 is 10,000.
Yes, sir.
And square of meter is meter square. So just if you square on both the sides, you get 1 centimeter square is equal to 1 over 10,000 meter square.
Sir, but wouldn't the answer be 25 newtons per centimeter square?
No.
Because the area of our pencil heel is 1 centimeter square, and there are two pencil heels holding up her weight divided by.
Just you have.
Because sir, this is an elongated version, I feel like. Because our answer. Hello, sir. Sir, you are frozen, sir. Hello.
So your voice is breaking.
Sir, you froze, sir.
Close, sir. We are able to hear slight voices.
No, some network issues are now. Sir, join.
Okay. So I know I was disconnected over here. So I think
Sir, your voice is breaking.
you know now how we got this conversion.
Sir,
Why
Nailika
still
was
breaks?
calling you, sir.
Sir, what I said was correct or wrong, sir?
Yeah, you said it's correct. Just divide it by 2. Yeah, it has to be 2.
Sir, it will be
Okay,
250
you are
Newton
correct.
per centimeter square or 25 kg per centimeter square. That's what it is. The answer.
Okay. So here you have just 1 minute. Yeah. So this is the area of 1 feet. Area of 1 feet is 1 over 10,000. Area of 2 feet. If you consider here area of 2 feet, so area of 2 feet will be equal to 2 over 10,000, right? So hence you can put here 2 over 10,000. So this will be not 1, this will be 2. Thank you. You will be using here 2 over 10,000. And hence if you divide it, you will get here 5 divided by 2, 500 divided by 2. So this you get 2.5 multiplied 10 to the power 6 Pascal. Is this what you are saying? Okay. Now let us
Sir,
find out.
but how do we
Yeah.
get 10 to the power of 6 Pascal? I mean, 10 to the
We have here 4 zeros here, 2 zeros here.
Okay, sir.
Okay. So we have 10 to the power 6 and 5 divided by 2 is 2.5. All right.
Okay, sir.
Okay. Now pressure exerted by the elephant. So for the pressure exerted by the elephant, again, whatever is the mass of elephant that will be converted to weight. So force would be equal to M multiply G. Mass of the elephant is given as 2000. You have 2000 multiplied with the G, which is 10. So you get the force as 20,000 Newton. Got it? The weight is 20,000 Newton or the force is 20,000 Newton. And now you find out the area of contact, area of the elephant. So again, the area of elephant is given as 25 centimeters square, but elephant has 4 feet. So you multiply this 25 by 4, that is 100 centimeters square. And you convert this 100 centimeters square to meter square. So as you know, 1 centimeter square is equal to 1 over 10,000 of meter square. So 100 centimeter square would be equal to 100 over 10,000. This would be 100 over 10,000. So you can just cancel and you have 1 over 100 of the meter square. Okay. Now find out the pressure exerted by the elephant, which will be force by area. Force is 20,000 divided by area, which is 1 over 100. So you get, yes,
2 million.
you have 20,000 multiplied with 100. So that makes it 2 multiplied 10 to the power 6.
Means 2 million.
Yeah. So which one of them exerts a greater pressure? The elephant or this girl's feet? For the girl's feet, you have the pressure as 2.5 multiplied 10 to the power 6. So it's 2.5 million. And for the elephant, it's just 2 million. So which one exerts a greater pressure?
Sir, it is the high heel, sir. Elephant.
Elephant or the girl?
The girl, sir, because she has a smaller area.
Yeah. No, we have
Right hand is
calculated.
smaller area.
It's not only the smaller area. We have calculated here the pressure exerted by the girl is 2.5 and the pressure exerted by the elephant is 2 million. Yes.
But uh, the elephant only, like the elephant only has more area, right, sir? Like, the elephant only has more area.
Yeah, elephant has a greater area. And we have calculated the pressure for both of them. So this is the pressure for the elephant, and this is the pressure that we have calculated for the girl, which is 2.5 into 10 to the power 6.
Sir, for
So
girl,
definitely.